Oh, there it goes. Okay, so half-life formula. N is equal to N sub 0 times 1/2 raised. I'm going to move that little line a little bit. Raised to the T over H power. Okay? So, obviously, this is my ending amount, how much you end up with. Oh, my word. Ending, I was trying to write the word ending amount. Do what?
E-N-I-D.
I know I wrote the D, but it didn't, this little loop doesn't do a lot of times. I don't know why. Okay, what's N sub 0? Yeah, first, beginning, initial, however you want to say it, people. Beginning amount. Alright, what does T stand for? Time. And what does H stand for? Yeah, that's your half-life. Okay? Now, no, it doesn't have to be. Okay? But here's, Dallin asks, does time have to be in years? So, y'all, it doesn't have to be in years, but here's what does have to be true. These two things right here, they must be in the same unit. They must be in the same unit. That means that one can't be in weeks and one can't be in days. Or
Is it supposed to be half-life or half-time?
oh, sorry. I don't know. It's halftime, people. Sorry. Well, you can tell when it gets close to the end of the year. You think the kids act crazy, boy, those teachers. All right. And I just had to walk down the hall, right, Joe? I mean, please. Oh, my gosh. Over here with the freshmen. Good night. They're just crazy. So, so here's my half-life formula. Okay? Here's the problem we're going to work. Example 10. All right? We got some radioactive strontium. I know that the one word tells me that, do I want to let my children play with it? No. Do I want it buried in my backyard? No. I don't want to be around it. Radioactive says it's not going to be healthy for me. Okay? So you have some radioactive strontium. Its half-life,
Will it always tell you?
sometimes they tell it in different ways. Its half-life is 28 years. Now, what does that mean? Its half-life is 28 years.
28 years will go to decay.
Yeah. In 28 years, half of it's going to be gone. Okay? If I started out with 5 grams of it, okay, don't write that down because I don't know. All right, I just made that number up.
How
did they figure that out?
Here's why they don't say the full life is 56. Think about this, okay? If I have 5 grams of it, in 28 years, how much do I have? 2.5. In 56 years, how much do I have? Do you see what's happening? Does it ever all go away? No, it doesn't. It approaches 0, but it doesn't ever get there. Okay? So, you just keep halving it. You just keep halving it. The next time, it would have, oh no, what would it have? 0.625? No. Oh, 625? Sorry. Sorry. And the next 28 years, 0.3125. Right? Okay? See? Look, y'all, this has been, here's 28 years, here's 56 years, here's 84 years. Uh-oh, we're getting above my head. Here's 10112 years, here's 13140 years, here's 140 years. Okay? People, I'm going to tell you what, just to get to right here, I'm probably not going to be alive. All right? I'm going to say I probably don't, I don't know that I have 28 years left. Okay?
Those things are good.
Yeah.
Now I'm sad.
That's going to make me 82. That's going to make me 82. I don't know that I'm going to live to be 82. Okay, well, I can tell you this. This one right here, I ain't going to be here. Okay? So, no, I don't think that'll be lucky to be 110 years old. Okay?
If you're like one of those people that are still walking on the track and stuff.
The lady I met
You're
at the
stuck at home,
doctor
it would be
the other day.
fun. Like, I was in my doctor, Mr. Parker. He's like, hey, man, guess how old this lady was? And I was like,
Oh.
70? I didn't want to be like,
Yeah,
I
right.
was like,
What's like 100?
He's like, no, higher. I was like, 80? No, higher. 90? Like, no. He's like, 100? No, higher. I was like, 105? Higher. She was 106 years old. She didn't even have a walker or anything. And she drove herself, everything.
So, here we go. We have radioactive strontium, half-life 28 years, okay? Here's what they're going to tell you. Y'all, they're going to give it to you different ways. They're either going to give you the info and have you put it in the equation. This time they give you the equation. They say the quantity of strontium present after T years is given by this equation. Y is equal to 10 times 1/2 raised to the T over 28. And then they start asking you questions, okay? One of the first questions that they ask you is, how much strontium do I start with? Yeah. 10 grams. Okay? So, 10 grams. You know that because that 10 is up there in the front of that. That's the, what do you call it? Yeah, that's that chemistry stuff. I'm not a chemist. I didn't take chemistry in college. So, yeah, that's what it's what is it called?
Atomic number.
Atomic number? Okay. So, here's the next question. How much do I have after 80 years? How much is left after 80 years? Okay? I'd venture to say in 80 years, most of you guys won't be there.
Show me early, you know. Show me early. In 80 years, we're all going to be dead.
I said most of y'all won't be here.
We'll be 107. Yeah.
We'd be 90.
No, 97. My bad. That was saying I want to be alive 97 if I want to.
Okay. Yeah.
There you go.
Oh, 10. Okay, good. All right, so here we go. Y is equal to 10 times 1/2 raised to the, what's T? 80. What's H? 28. They have to be in the same units, guys. Okay? So now you're just going to put it in your calculator. Y'all don't do it a piece at a time. Okay? What?
No.
What did I do wrong?
I don't know.
Start off with that.
I'm going. It's a half-life, not 1.5 life. What? 1.38 grams. 1.38 grams. Very good. Okay? All right. Here's the next one. Example 11. The famous fruit fly problem. Okay? Alright, here we go. The approximate number of fruit flies in an experimental population after T hours is given by this equation. Q of T, the quantity with respect to time, is 20 times E raised to the 0.03 T. Alright, now just because you guys are so smart, can you tell me my initial amount or number of fruit flies?
Oh, I got a fact for y'all.
Huh?
What is the most consumed fruit in the world?
Oranges.
Mangoes.
I love mango.
Really?
Yeah. An apple. Real fast.
That's my favorite one.
I like the one that said hedgehogs can float in water.
Okay. The initial number of fruit flies. Guys, listen. Initial number of fruit flies. How many? 20. Everybody got it? Okay. Tell me, are the fruit flies increasing or decreasing? They are increasing, okay, at a rate of what? 3%. Wasn't even here yesterday, people. 3%. 0.03 represents the decimal equivalent of that, okay? So be careful that that is a decimal equivalent. This is the percent. Now, here's what I want to know. How many fruit flies in 72 hours? How long is 72 hours? 3 days. So y'all are just going to plug it in. 20 times e raised to the 0.03 times 72. Because it said t, it told you in the problem. I read it, but y'all, it says t was the time in hours. So you had to leave it as that 72. Okay? No. So, yeah. Oh, wait, I got it. Yeah, sorry. Next time you just need to stand up, I guess. Okay, so, oh, let's talk about that. What'd y'all get for the answer? 174 point...
Oh, no, 173.
173 point what? 423? Okay, so we'll say 4. 173.4. All right, good answer? Why? Yeah, you can't have 0.4 of a fruit. We don't want 0.4 of a fruit fly. I don't want any fruit flies, but whatever. So what is it? 173 fruit flies. Okay? So what if it have been 173.9 fruit flies? It's still 173 fruit flies. Okay? That 0.9, that's not a fruit fly yet. He's almost there, but he's not there. So, okay? Anybody got a question? All right. Oh, that's okay.
I had a question. Like, what if you were trying to find
Ah, we're going to talk about that, Brent. Matter of fact, let's just talk about it right now. Okay? I could talk about it as far as the half-life goes. Here's what Brent says. Brent says, what if I know how much I have left, and I know what my original amount was, and I knew how long it had been there, but I didn't know what his half-life was. Could I figure out what his half-life is? I'd have to solve for that h, right? Okay, so some of you are like, oh my gosh, that's so stupid. I'd never want to know that. But what about this? Okay, what if oh, you crazy machine. I don't know, something about putting it up in that little holder is making it connect again. All right, what if I had $5,000, okay, and I invested it and it was earning at a rate of 5% or 4%, okay, compounded every month. Every month, so n is 12, raised to the 12 times t. How long would it take me for that $5,000 to turn into $15,000? Now that's a very good question, isn't it? That might be something that might happen to you. All right, you got your 4 kids. All right, and you know one of them sooner or later is going to hit 16. And you said, maybe I'm not going to buy them a car. But your wife said, what? Yeah, you are, because I'm tired of hauling them around everywhere. I need another chauffeur, right? I need some help around here. And so you like going, well, this is all the money I got right now. So how long is it going to take me to turn that $5,000 into $15,000? Okay? This, do you know how to solve for that exponent right here? That's exactly right. That's what logarithms are for. So the very next thing, this is driving me crazy. The very next thing, it's okay, Dylan. The very next thing that we're going to talk about is logarithms. Okay? So that's section 2. Why do we have logarithms? To find exponents. Logarithms and exponentials are inverses of each other. Okay? So we use one to find the other one. Alright, so first of all, let's just talk a little bit about logarithms. This is 3.2. You don't know how to do it. But that's what we're working towards. Okay? Logarithms. Now, anybody know what a logarithm is? What? No, it is an exponent. Remember last year we wrote it 3 times. We're going to write it 3 more times. A logarithm. Why am I making you write it 3 times? So, well, obviously 3 times wasn't enough, right? Maybe we should write it 6 times. You wrote it 3 times last year. Okay? So a logarithm is an exponent. A logarithm is an exponent. I'm going to write 3 times. No ditto mark. A logarithm is an exponent. See what? Did y'all know that Miss LaBeouf came in here earlier and she said, I didn't know that. She went to college and took all those math classes and everything. Nobody ever told her that. She didn't know that until she started teaching. And she was like, I just don't get logarithms. So I was like, oh my gosh, it's just an exponent. And she was like, what? And then she was like, then all the rules made sense. And I said, yeah, because they're exponent rules. And she goes, yeah. And she said, I hated logarithms till then. And now she likes them. And I said, I tell my kids that. I make them write it down 3 times. All right. So the first thing we want to do is we want to learn how to write a logarithm correctly. All right? So I'm pretending like this is my notebook paper. Okay? So this is what it looks like. Y is equal to log. I always use cursive letters when I write log because one year I didn't and I wrote it like this and everybody thought it was what? 10 G's, okay? So now I always use cursive. Y is equal to log base A. Now look where I put this A. Is it on the line below it? No, it's not. Is it on the line with it? No, it's just below. It's like a subscript is what it looks like. Okay? Log base A of X. Y is equal to log base A of X. And here's how you read it. It is, oh, no, I don't need to say the word red. Red. Log base A I don't know. It's been messed up all day today. Log base A of, that's the word of. I don't know why y'all don't know that's an F, but. Of X. And close the quotation mark. Dadgummit.
Why do you do the O in cursive? Why do you do that in cursive like that?
I just did.
That like it?
Yeah, I guess so. Alright, so here we go. This is called log form. And you have to be able to write it in exponent form. When you first start doing logs, this is how you learn how to do logs. You take it in log form, you rewrite it in exponent form, and then you'll know the answer. Okay? Alright, so we're going to write it as an exponent. What's my base? What?
A.
Yeah, it says log base A. So base is A. Alright?
Okay.
What is my exponent? Look, watch over here. Are you watching right here?
Yep.
A logarithm is what?
An exponent.
A logarithm is an exponent. A logarithm is an exponent. What's my exponent? Is equal to, that guy's my answer. So a to the y is equal to what? X. Very good. Now we're going to go over there to that logarithm part, and we are going to write what everything is. I'm attempting to.
Is that something you were putting in it?
No, they're not. They haven't gotten to logs yet. All right. So what's this guy right here? He's the exponent. Okay. What's this guy right here? He's my base. Huh? Because this is the way kids write it sometimes. This is the way that these are the things that I see that I told them I'm counting off for them. That's the way they do it. I'm like, that's not the way I taught you how to do that. And here's the other thing I see. These are two consistent things I see all the time. Dadgummit. That's a scream. Get on my nerves. I just don't understand it. Some days it does so well. I got it. And the other way I see it is like this.
I don't think it ever does good enough by
Both of those things right there say that kid doesn't even know what they're talking about. If I was a college teacher and someone wrote that on a paper, I'd be like, oh my word, they don't have any idea. You see what I'm saying? He's making a judgment call, but he's going to. He's going to make a judgment call. And once he sticks that label on you, are you ever going to get it off? You're not going to. You're not going to. So,
reoccurrences can change.
how many? 20 what?
Positive reoccurrences
Can change one negative.
can change your look at new impression.
Your impression. Oh, your first impression or just any impression?
Your impression.
Okay. All right. So this is my what? This is called the answer. All right. So let's work some problems. You ready? Come on. It's gonna be fun.
Yes.
All right. Log base 2 of 4. Now, how are we going to work it? People, we're going to go over here and we're going to write it as an exponent. Oh my gosh, I don't think I can stand this thing anymore. Too bad if you can't hear me on the intercom. I don't care. Okay? I do really, but
She's rude. Told y'all.
anymore. All right. So I'm going to write it as an exponent. What's my base? I didn't wear the right shirt. I've been fighting that all day. Every time I sleep against the thing, it makes me kind of credit. Right, 2. What's my exponent? Yeah, we don't know. It's equal to, what's my answer? So 2 to the, what power is equal to 4? So log base 2 of 4 is 2. Perfect. All right, my next one. Log base 2 of 32. Oh, we're going to see if you know your exponent.
Probably not.
Okay? Here's what it's asking, guys. It's saying 2 to what power is 32? Yeah, 5. It's the one you should know. Okay? You should know 2 to the 5th is 32. All right, here's the next one. There you go, Kane. That was just for you. Log base 5 of 25 is what? 2. Why?
Because 5 squared.
Very good. It's 2, guys, because 5 squared is 25. That's what logarithms are. Logarithm is an exponent. It's just what exponent do I need to raise that base to that power to get this number. All right, what about, here's a hard one. Ready? We'll do one hard one, then we'll quit. Log base 2. No. Sorry. Erase it. Log base 4 of 2. Log base 4 of 2.
Oh, this one, no, can we say it out loud?
You can.
Well, never mind, never
What is it?
Say it out loud.
1/2.
Oh, okay, that was my guess.
Yeah.
I didn't let her say it and look stupid.
Okay, no. We need a 4 to what power is equal to 2? This one's harder because you're making something smaller, so you know you can't be raising it to like an integer power, right? So it is the square root of 4 is 2, and remember, rational exponents, roots go on the bottom, so that will be 1/2.
Didn't I still not get the
Yeah, we had part of it that you didn't.
Is that gonna have to do?